Hello, everybody, and welcome once again to Detect and Protect, the Australian Biosecurity Podcast. I am your host, Steve Payos, and I'm very happy to be hosting this podcast series, which is all about sharing information on biosecurity and the difference that this makes to our everyday lives. Imported live plant material can introduce foreign plant pests and diseases that could be harmful to Australia's environment, agriculture, and economy. That is why we have strict biosecurity requirements for plant materials that enter Australia. Today, we're going to delve into the Plant Innovation Centre at Post-Entry Quarantine, also known as PIC at PEQ or Pick. I must say, I do love that name. We've spoken about post-entry quarantine before on this podcast. It was episode 5 for anyone that is interested, and is definitely worth a listen if you haven't listened to that episode before. For those of you who might have missed it, post-entry quarantine is essentially a period of time that animals and plants, after they've arrived in Australia, undergo so that they can get the necessary tests and checks to ensure that they've met permit conditions and are free of exotic pests and diseases. The Plant Innovation Centre plays a vital role in identifying, developing and delivering new and innovative diagnostic and treatment technologies to improve Australia's capacity to address current and anticipated plant biosecurity risks. Joining me today is Dr Adrian Dinsdale, Assistant Director at Pick, who is leading a dedicated team of plant scientists and is here to tell us all about the fascinating advancements in detection technologies and business practice innovations that the team have been working on. Now, this is a fantastic space that the department has developed so much over the last few years. Innovations are becoming such a big part of the business, and I'm very, very excited to hear all about this. So thank you very much for joining us today, Dr. Adrian Dinsdale. Good morning.
Thanks very much, Steve, and thanks for the invitation. It's a pleasure to be here.
It is. No, it's very, very interesting. I'm very much looking forward to this discussion all about technologies and the work that you're doing at Pick. And thanks for filling me in on that name, I must say. It's very, very interesting, and it's a good way to talk about the centre. So let's jump right in now, Adrian. Can you please give us a quick rundown on what the Plant Innovation Centre does and why it is so important for our biosecurity?
Thanks very much, Steve. So Pick, or the Plant Innovation Centre, as the name implies, is a team of innovation scientists, and we're based here at the National Quarantine Facility in Melbourne. And our job is to do exactly that. It's to innovate. So we are a real practical and applied hands-on team of scientists. We don't just work at computers. We have laboratories and we work at external facilities. And it's our job to find ways to manage the risks at the border that we always do, but to do that faster, smarter, cheaper, and so on. So we can manage the risk of the increasing burden of exotic pests and diseases that are coming into Australia. And it's really important to do this because the movement of people and goods globally is increasing drastically and is forecast to continue to do so. And we can't just keep throwing more and more people to inspect more and more goods. The cost and the time to do that just isn't sustainable. So we really need to find technological and innovative solutions to keep on managing that risk.
Now, the last 2 years, we've seen a pandemic where the movement of people has almost come to a complete standstill, but the movement of goods, where it's been possible, has probably ramped up a bit. How much of an effect have you seen because of that, and how much has that meant that you've had to, I guess, speed up the innovation or really think hastily about how to manage that influx of goods?
Yes, Steve. Look, that was a big challenge for the biosecurity across the business, really. We were fortunate that with that increase of goods, as you mentioned, came the decrease in the movement of people. So we were able to redeploy a lot of staff who were inspecting goods and people coming in through airports to instead start inspecting goods at docks and also in planes. So I suppose the silver lining for the pandemic for us here in what we do is that it really sharpened people's awareness of the need for biosecurity and the impact that biosecurity failures can have on all of us in all parts of our life. And so that's been that's been, I suppose, ironically, quite good for us, because it's been a way for us to get better support and to demonstrate the importance of innovation to keep on managing those kinds of biosecurity risks and hopefully prevent those kinds of outcomes in the future.
I know biosecurity risk innovation has been a big part of the department's focus. I was involved in one of the seed challenges that took place a few years ago, where it was, pitching, getting, private sector to pitch ideas and, in line with all the great innovation work we've been doing. So I know it's such a big focus and moving forward, and that's why the work you're doing is so important. Can you tell us a little bit about your role at Pick Peck, the involvement with biosecurity itself, and sort of how long you've been there and what's happened to the team in that time?
Yeah, so I joined the Pick Peck team about 3.5 years ago. It was a very small team back then. We consisted of all of 2 people, and one of those only worked in our team 1 day a week. So quite humble beginnings. It was a real...
Nice and small to start with, yeah.
Yeah, yes. I suppose I saw it as a great opportunity to come into a new team, a new idea, and really try and build it and mold it into what we thought was what our biosecurity system needed. So I came from a background more operational, but still very much a science background, working in diagnostics. And so since then, we've now grown to a team of 10 people, and that's been really gratifying to see that the results we're delivering have produced improvements and outcomes that have fed back into the success of the team, so we can keep improving and building on those improvements we've been able to deliver. And before that, I also worked for many years in sort of state government as well, and also in various science roles in both in industry and in government.
Superb. No, that's great. And we can see with the expansion of that team and expansion of everything around you, how serious everybody takes this, as well as coming to, identify and develop those new project ideas. And that's something I'm going to ask you about in just a moment's time. Before that, can you tell us about the work that you do and how that affects the everyday Australian? And I guess for the layperson, it's always something that's interested me in terms of, if diseases came through. And first, to put my hand up to say that before I joined the department going back 6-7 years ago, biosecurity was something that you really needed to get a full grasp of, to understand. But once you get it and know what that devastation could be to fruit and veg crops, to livestock, the impact is potentially so big that it's not funny. It's very serious stuff. The impacts in dollars, the impacts in what happens to us being able to enjoy our bananas or our avocados or whatever that case may be. And I'd love for you to tell me a few instances and examples of how that work affects the everyday Australian.
That's a great question, Steve. And I love this question because one of the cruel ironies, if you like, of what we do is that when nothing happens, that means we have done our job and we've been successful. But that does really make it hard for people to, understandably grasp, I suppose, the importance of what we do. And I suppose, as I mentioned, that's been sort of one of the silver linings for COVID. It has sharpened people's awareness, but we obviously don't work in the human health space. We work in agriculture, but that doesn't make the impacts of some of these things any worse. So some really good examples. One I like, which people may have heard of, is called the brown marmorated stink bug. And this one's quite important, not just because it's an agricultural pest, but it's also a real social pest. So even if you are living completely removed from food and agriculture, and of course, we all eat, so we don't really. But the brown marmorated stink bug can build up to huge numbers. And we've seen for when it's successfully managed to infest areas in the US, that what happens is that over winter, it likes to find little nooks and crannies to hide in. And they've been known to go into people's homes literally in the thousands and crawl into, your remote control, into your cutlery drawer, into your socks and undies drawer. And people get up in the middle of the night and get up for work, pull out their undies, pull them on, and they find stink bugs in their. So it's not just about having apples that don't taste good anymore. It goes beyond that. And some other good examples are so in Australia, we really only grow predominantly one type of banana called the Cavendish banana. You can't import bananas into Australia. They're far too big of a disease risk. But there's a really devastating disease called Panama disease, which has been found in a very small number of properties in Queensland, but we've been able to actually contain that and keep it just in those properties, and we're the only country that has managed to do that. And that disease completely wipes out those Cavendish bananas. And so because of our success in doing that, we still have high quality, tasty, affordable bananas on the shelf. And there's lots more examples. I could reel off heaps. There's xylella with grapes, and there's rare imported fire ants, which sting like all hell and are present in Queensland. But again, we've managed to contain them, and I think are the only country that's managed to do so. But maybe I'll leave it there, Steve, because I could talk your ear off.
That'd be great. Well, that's what we're here for. Xylella is the number one risk. Is that right, Adrian? Well, it's one of the top risks in terms of our diseases. Is that right?
That's right. It's the number one priority plant pest for a whole lot of reasons, but the main one is if it got in, the cost would be literally in the billions. It can infect hundreds and hundreds of hosts. Grapes is just one of them. Lots and lots of fruits and vegetables would be really badly impacted by this if it got in, and it's transmitted by insects that suck on the sap, and we obviously have lots of those in Australia. And the impact on our native flora, we don't even really have a good understanding of what that would be. So it's really quite scary, that one.
Yeah, and I've heard a lot about that one, noting that it's a big one. So something we need to be very, very careful of. In a moment, Adrian, I want to ask you about what some of the projects are that you're working on, and I know that you'll probably be able to talk to me for a while about this, which is really exciting. Before that, though, I'd like to just quickly ask how you come up with the projects and the concepts behind the innovative projects. Is that something that we sort of, really sit down and think about for a long time? Is it a little bit more, reactionary based on the changing environment or that sort of thing? I'm very, very curious to hear about how you come up with the ideas and for some of these project concepts that you look after.
Look, I think the short answer is it varies. So some of it, like you said, some of it is reactionary, but we try not to be reactionary. That's not really the good way to do what we do. But sometimes priorities demand us to do that. But this is really one of the great parts of my job is that I need to be aware of new and amazing innovations that are occurring out in industry. We're not really the kind of outfit that goes and does from the really ground up kind of blue sky pure research. Like I said, we're looking for solutions that we can implement that are practical. So I actually spend quite a lot of time and energy just sort of keeping my ear to the ground, as it were. So I do a lot of networking, I do a lot of reading, I do a lot of meeting with people, and just making sure that I'm aware of the developments that are going on across the world to develop new technology that might be useful and applicable to us. And we also work quite closely with industry. I mean, industry often have a good idea or good ideas of ways that could improve how we do business. And so it's really important to keep those communication channels open. Likewise, we try and interact with a lot of our colleagues in universities and state governments, organisations like the CSIRO. And so when we come up with ideas, it's quite common for us to then partner with an external agency so that we can leverage their expertise and knowledge with our knowledge of what we need to get out of an innovation to make it work for us, so that essentially we can be sure that what comes out at the end is actually fit for purpose.
Yeah, absolutely. And that's one thing I know with the partnerships of the department. I've seen a lot of partnerships with the CSIRO. I've heard presentations of the work that we're doing and those partnerships that we go into to really expand on the work we're doing. And I think that's very important as well, because it'd also be that the university sector, is that right as well, where we've got people that are in there doing studies and being able to pass on research, for example, to assist us with all of that type of work would be a big part of that. Is that fair to say?
It is. A lot of it is the department directly funding external research, but what we are doing more, and our group has done a lot of work in this space, is to really mature that relationship. So, for instance, now we actually have a PhD student now working in our laboratories here in the department, being co-supervised by a university. So that's a first for us. In the past, we have paid for this kind of work to be done in the labs of universities, but never has that work been done in our labs. So that's a really good way of not only building those networks and that expertise and that knowledge with scientists in the university sector, but it's also, like I said, a way of making sure that the projects that come out of that really meet the needs of biosecurity.
Mate, how monumental is that? The fact that we've got, a student that's being supervised, directly by us in the department. That must be a massive step forward in terms of, actually having that, as in, I guess you could say, embedded within what we do. No doubt we've had the previous partnerships before, but to actually have them in here, that sounds absolutely magnificent.
Yeah, it's a funny thing, Steve. It doesn't sound on the face of it that massive, but it really is. I'm particularly proud of this one. This has been my baby for several years, and it's quite literally been years of work. It sounds like something that is not very complicated, but when you think about when you do this kind of research, you're literally creating intellectual property. And so there's a lot of nuances you have to work out with your external partners about, well, who owns it and do we share it? And if we share it, how do we share it? If you're going to use it, and then can you sell it to someone else? And can you make money from doing that? Or can we? And who has control over that? And who can talk about it? Is it private? Is it secret research? All those kinds of things have to be considered before you can get these programs off the ground. So it was a steep learning curve for me. I'm a scientist. I don't know about contracts and lawyers, so I've had to learn quite a bit about that. But what it really came down to was just being able to engage with people and work with them and find a way to get to an outcome that meets everyone's needs. And I'm really optimistic that this will be the first of many students that we will embed within the department, and hopefully, the benefits from that, I'm sure, will be massive in the years to come.
And you should be proud of that. Like you said, if that is your baby, I think that's something that, to me, it's something that you can really, progress and really get that excellence in knowledge as we push forward, because it's a great idea to do that and to embed that. And I think that's something that's only going to improve us in our own right. So well done on that, Adrian. All right, let's talk about some of the really exciting stuff. What are some of the projects that the team is working on at the moment? And I guess what you can tell us on this is something I'm very excited about. So please take it away.
Wow, how long have we got, Steve? Don't know. I'll try not to. I'll try not to go too long. So our treatments mostly, not entirely, can be broadly split into sort of two categories. So we do a lot of work in diagnostics. So that is work to detect and identify exotic pests and diseases. And the other main, arm of what we do is more about treatments. So finding ways to treat goods so that we don't need to try and detect pests and diseases, because we can be confident that they've been managed. So treatments are always great where we can do them, but they're a very blunt tool, and oftentimes we can't use them because they will damage the things that we're trying to protect. So particularly with things like fresh produce, they're very sensitive to a lot of treatments. So we play with things like gamma irradiation and electron beams to try and find new ways to treat things, to manage the biosecurity risks without harming the goods. Likewise, we even do pretty unsexy science, really, with things like humidity and dry heat to try and do the same thing. They're not very exciting tools as a scientist, but we're really about just doing what is best to protect our environment, our agriculture. Whether it's sexy or not, that's very much a secondary thing. On the other side, with the diagnostics, which is a bit sexier, if you ask me, as a scientist, we have some really amazing technology that's recently become available. So, for instance, here where I work at the quarantine facility, in the past, if we had identified an exotic pathogen, it would take us up to a week to get a DNA sequence on that to be absolutely sure of the identification. We've been using some new tools here, using something called a MinION, which uses a technique called nanopore sequencing. And now we've been able to show in our lab that we can do that in a matter of hours and get exactly the same result with the same level of confidence. So that's going to be a massive improvement. So when you've got a shipment of goods waiting at the docks, for instance, and it's perishable, you can't wait a week in the summer to see if you can release that shipping container of broccoli, for instance. But now that we can do that in a few hours, that's a feasible outcome. So, massive savings all around in lots of ways.
How much does that mean when it comes to the identification for unknown specimens then when we talk about the MinION? And it's got to do with DNA sequencing and that sort of thing. Is that right, this technology?
That's right. Yep, that's exactly what it does.
So with that, what in terms of the fact that we're trialing that and that sort of thing, what does it mean in terms of that identification process, and how crucial is that, I guess, to in terms of identifying that specimen in a timely manner?
Right. So previously, if a consignment had to wait, like a week or thereabouts, the importer was really left with a quite difficult decision. They had to either send their goods for a treatment, which possibly they may not have needed, which is going to impact the quality of their goods, or they could have elected to just cut their losses and destroy it. Or the only other option is to get back on their ship and try and sail to another port to find somewhere else they can try and offload. But again, the costs of doing that, the time with fresh produce means drop in quality. All those things are critical. So if we can clear these goods faster and cheaper, and the importers bringing them in have more confidence bringing them in, then improvements on the supply chain all around for industry, for consumers, for retailers, for everyone.
Yeah, these advancements seem, incredible for me. And as you're talking about, that's going to be a thing moving forward. I know we've seen, lots of instances where you might have a ship that's come in, it's stuck on port, or it needs to go back out to sea, whatever the case may be. If we can detect these things sooner rather than later, then that's something that's going to be hugely beneficial for us as a department, for the importers, for everybody that's involved as well. So there's no, loss of product, money, all that sort of thing that comes with that, which is very, very important. What can you tell us, Adrian, about high throughput sequencing, HTS? And now I understand that this has been described as a bit of a game changer for detecting and identifying viruses in high risk plant products imported into Australia. You'll know all about this, but I'm very interested to hear about it. What can you tell us about HTS?
Yeah, thanks, Steve. Look, high throughput sequencing really is going to be a big improvement for how we do our business here, particularly at the quarantine facility. So at the moment, people would probably be surprised to learn that just one plant that comes here into Australia, if it's a high-risk plant, on average, they would spend anywhere between 6 months to 18 months, or sometimes even more, here in quarantine before they can be released. And while they're here, they're undergoing a whole range of tests for all kinds of nasty pests and pathogens. And that, of course, is not cheap. It's expensive. So we're trying to find a way to do that faster and cheaper whilst still being confident about managing the biosecurity risk. So the way high throughput sequencing will really improve what we do here is that it can detect every single virus in a single plant in one test. So with this one new test, we'll be able to phase out over 100 pretty inefficient individual tests with just this one test. So that will reduce the number of tests we do here every year, literally by several thousand. So what that means for industry is that they can access the latest and the best plant genetics that have been bred overseas. They can access them faster, cheaper, and with a lower biosecurity risk, and that will flow on, down the chain. Because if industry can access better plants sooner, then they can produce better quality produce sooner, that better quality produce has all kinds of benefits, more disease resistant, more tolerant to environmental stresses, and so on. So yeah, this is going to be massive for us.
Great stuff, mate. That is so good to hear. What do you think is your best story about the diseases and insects you've found or detected? Do you have something that's a real standout in terms of, a plant perhaps that was about to leave quarantine and then a test was conducted that found Xylella, or let's say perhaps you found a disease that had never been detected before? It sounds like you've got some fantastic stories. So what would you sort of deem as the best one that you've got?
We have found a few new things to science here. That's always pretty exciting from a, scientist nerd point of view, but that does still happen. So actually just last year we found an entirely new virus. We found it in a grass. So people do import grasses through here. This one was so in the end, we actually had the pleasure of being able to name it because we found it. So it's pretty exciting. Hold on to your hats. It's called the Miscanthus sinensis mosaic virus, which rolls off the tongue. But we actually quite literally just published that in a scientific journal this week. It got officially released for publication. So that's really exciting. And we actually found that using high throughput sequencing with some of our trials here, which just demonstrates its value because not only does it detect all the viruses that we know are out there, it can detect the viruses that we don't know are out there, which our previous tools could not. So that's really amazing. In terms of, real bad boys that we know are biosecurity risks and that we have come across here, I might actually refer to one of my previous role where I worked in the diagnostics section. So in our team now, we do R&D, so we don't really detect things at the border. We're more about finding ways for other people to detect them. But quite a few years ago, we had a plant that came through here and it was literally on its very last day in quarantine. And the very last thing we do before we release a plant is we have an experienced plant pathologist literally give it a thorough inspection. So just looking at it, usually under a microscope, and just making sure it looks healthy. And at that very last check, we detected something that looked not quite right. And closer examination, we discovered it actually turned out to be something called chestnut blight, which is a really devastating fungal disease on, as the name implies, chestnuts, but also other plant species as well. And so we prevented that incursion. And this was quite a few years ago. Really sadly, some years after that, chestnut blight did actually make its way into Australia, and the Victorian government is now battling an incursion of that.
Wow.
But, we managed to basically keep that industry safe for many more years because of that detection.
Well done. That's fantastic news there. And that goes to show that almost doing a one last spot check is, can be the most important thing. Like you can do follow all the rules, follow all the processes, but sometimes it's just that one last check. I guess in a weird way, like before you're leaving the house, for example, all right, one last check. I've got everything, but then you do that one last check, and here you go. You're talking about that, and we found something that is very, very significant. So well done on that. It's the work that you're doing down there is fantastic, Adrian. I'll just ask you one last question, which would be something that I want to talk about with regards to the future. Can you tell us about any exciting projects that are upcoming we should keep our eyes out for? It sounds to me like you've got some incredible things happening at the moment, not to mention a few of the new technologies and things that we're working on at the moment. But what's coming up in the future that's exciting you the most?
Well, very timely question, Steve. So literally this week, we just had 2 new projects that that we've confirmed that will start in July. And stop me now because I'm going to go into full-blown science nerd phase because it's pretty exciting stuff. Here's
your chance, mate. Here's your chance. Last question of the day. Fill me in, please.
So this is a twofold project. One of the projects is in partnership with RMIT University in Melbourne, and the other one is in partnership with the University of Southern Queensland. And what we are developing with both of those partners, with RMIT, we're developing something called a lab on a chip, which basically uses nanoparticle technology to create a tiny, tiny little integrated circuit which can detect diseases in something the size of a coin. And so the theory is that you can take that into the field and do really sensitive and targeted surveillance really quickly, cheaply, and easily with confidence. Running in parallel to that will be this project with the University of Southern Queensland to develop something called microneedles. So the only problem with that lab-on-a-chip type approach is that you need a clean sample, if you like. You can't just rip off a bit of leaf and stick it in the machine. You need a clean piece of DNA, as it were. And that's quite tricky to get out of plants, much harder than it is from animals, for instance. But the project we're doing with the Queensland group using these microneedles will allow us to create a patch that you can just simply push it into the plant and instantly you will get a clean DNA extraction. So our dream, the product we're aiming for with this project or projects, is to develop a fusion product, if you like, with a lab on a chip connected to a microarray that you can then get instant disease detection in the field kind of anywhere. So, we're still some years off really before we'll get there, but it's just another great example of us being out there, identifying new technology early that has passed the proof of concept phase. So we know it can work. We know it will potentially do what we needed to do, and getting the people together with the knowledge and the expertise to produce something that will really benefit what we do.
That's incredible, mate. That sounds unbelievable as we move forward. And I hope that you can continue to come up with all of this technology, advance everything in the way that you're doing, and really achieve all of the great things that you're doing at the moment. So, Adrian, thanks so much for all that information today. Extremely exciting. I very much enjoyed that, and I know our listeners will too. That was incredible. So, Dr. Adrian Dinsdale, thank you very much once again for joining us on the podcast today, for your insights into the projects at Pick Peck and the impacts on Australian biosecurity. We'll be keeping our eyes out and peeled for the future advancements and innovations. Thanks very much again for joining me.
Thanks very much, Steve. It's been my pleasure to be here. I'm really happy to talk about science and innovation any day of the week.
Thanks, Adrian. And a big thanks to all of our listeners for tuning into our podcast. You can find out more information on Australia's biosecurity on the department's website or by visiting biosecurity.gov.au. Make sure you subscribe to our podcast series to get updates on future topics and learn more about Australian biosecurity. Thanks very much for listening, everybody, and we'll catch you on the next episode of Detect and Protect.